Welcome everyone to this series of webinars on sequential decision optimization with media mix models. This webinar series is tailored for marketing professionals and individuals working with business intelligence. It will feature content that spans from slightly to highly technical. In the previous session, we discussed basic media mix models, what they describe, and the dynamics in our environment. In this session, we will discuss correlation versus causation, causal graphs, the exploration versus exploitation trade-off, and sequential decision optimization. We have also released a preprint of a formal report aiming to depict our approach to budget allocation between marketing entities. The third and final session will review and discuss the most important topics of the report. I also like to emphasize that the initial two sessions are tailored for marketing professionals lacking a technical background, while the concluding session requires a certain level of familiarity with machine learning, causal inference, and control. To my fellow developers, researchers, and professionals with a technical background, I strongly recommend delving into the report and attending the final session, as you will likely find it more captivating than the two initial sessions. Let us start off by reviewing the key points from our last session. Our focus in the first session was centered on media mix models and their components, including ad stock, saturation, time-varying factors, and synergies. We also discussed some challenges that demand our attention when we try to model marketing responses such as sales. One challenge revolves around endogeneity issues, where an unobserved variable influences both our independent variables and our outcome variable. Another challenge is multicollinearity, a situation arising from advertisers adjusting budgets simultaneously. This concurrent budget tweaking, such as decreasing or increasing budgets for two campaigns simultaneously, or decreasing the budget for one campaign while increasing it for another, complicates our ability to discern the individual impact of each campaign on the outcome. At times, we also encounter datasets with low variance in expenditure. Advertisers, in general, tend not to adjust their budgeting daily or even weekly. Instead, they devise budget plans for long horizons, whereas the budget is constant over the horizon for each campaign. Furthermore, advertisers tend to experiment infrequently, and when they do, their decisions often lead to significant multicollinearity. Furthermore, we need to accommodate our system to handle cold starts, where the advertiser had just started fresh with advertising and has no historical data. Moreover, our primary objective is to solve an optimization problem rather than just analyzing data. We are primarily focused on creating a budget plan that maximizes sales, not solely grasping the impact of different marketing campaigns. While understanding campaign impact is crucial, it solely serves as a tool to achieve our main objective, which is developing a budget plan that maximizes sales. So today, we will discuss how we can address some of these issues with sequential decision optimization. But to do that, we need to understand the environment and the cause and effect relationships between variables in our environment. Thus, we start off by discussing predictions versus causal impacts. At times, it seems that marketing professionals find it difficult to understand that predicting outcomes, such as sales, and inferring the causal impact of a marketing investment are distinct objectives that may require different approaches. We will then proceed to discuss correlation versus causation, which is strongly related to predictions versus causal impacts. There seems to be quite a lot of misunderstanding with regard to correlation and causation. And I have personally seen a lot of inferences that could be invalidated due to the question we're trying to answer being of a causal nature and the explanation solely relying on observed correlations. Having discussed correlation versus causation, we will discuss causal graphs, aiming to depict cause and effect relationships in an environment. We will discuss what they are, their components, and why they are useful in our context. We then discuss how we can model the cause and effect relationships in our environment and the issues that can be inferred from these graphs when attempting to model marketing response. We will then proceed to discuss the actual decision making. In the end, what we really want is to devise efficient budget plans that maximizes sales. We will review the conventional approach to decision making when allocating budgets between marketing entities. We then take a look at an important aspect of decision making that has been overlooked in the literature on budget allocation in marketing, namely the exploration versus exploitation dilemma. We then take a quick look at sequential decision optimization. And finally, we present our approach to budget allocation. Predicting something and inferring the causal impact of something are two very different objectives and should, in a lot of cases, be treated very differently. First of all, predictions are important. Obviously, it is always great to be able to provide reliable predictions of outcomes, as it will facilitate planning for our clients. However, in the general case, what we really want to do is to allocate budgets between marketing entities such that we maximize sales. Thus, what we really want to do is to understand what will happen if I increase the budget with X amount in marketing entity Y instead of Z. Or looking in retrospect, what would have happened if I increased my budget with X amount instead of Y? Now, compare this with the question, if I observe that my budgets were X and Y at this particular time step, can you predict the outcome that occurred? These questions are very different, and they may require different modeling schemes. For example, if we had just been interested in prediction, we could, for example, opt for a black box model that predicts well, but we cannot really understand why it predicts as it predicts. However, if we want to understand what will happen if we increase our budget on marketing campaign X, we need to understand the cause and effect relationships in our environment. Only then will we be able to create effective models and come up with optimization schemes that can address the issues that may be inherent in our environment when we try to model marketing response. And I want to point out that I'm not saying that predictions are not important. Obviously they are, since they will guide our optimization scheme. And furthermore, for our clients who set a return on ad spend target and aim to maximize spending while ensuring that the return on ad spend stays above this target, it is important that we can predict accurately, since a bad prediction will lead to overspending or underspending. What I want to point out is that it's important that these predictions are based on knowledge about the causal relationships in our environment, and especially the causal effects on sales. For a lot of clients, we would probably be able to predict reliably with just data on months, weekdays, and special events. And of course the historical outcomes. But that would not tell us much about what would happen if we change our budget plan for our marketing campaigns. Having said that, we will now take a look at a strongly correlated topic, namely correlation versus causation. Many of you have probably heard the term correlation does not imply causation, although many seem to fail to apply the comprehension of this into their daily work of analytics. To understand the term and its consequences, let's digest the two terms correlation and causation separately. First off, correlation describes an association between variables. It is a symmetric relationship. If X correlates with Y, Y also correlates with X. On the other hand, causation describes productive influence between variables. It is, in general, an asymmetric relationship. In general, if X causes Y, Y does not cause X. The exception being simultaneity and loops. Now, why is this important? Notice that we established in the previous slide that the main question we want to ask ourselves is, if we increase the budget for marketing entity X with Y amount, what will the outcome be? Thus, we need to understand the productive influence of X on the outcome, not the association. It could be that this association or correlation that we may observe in our data is due to another factor that we cannot observe and that influences both our spend on marketing campaign X and the outcome sales. This is what we refer to as an unobserved co-founder. To understand this, assume that you wish to understand the impact of paid search expenditure on sales. Let's assume that you set uncapped budgets for paid search expenditure along with a ROAS target in Google, and let Google decide how much you will spend based on the return on ad spend target. What probably will happen is that Google will increase the budget when demand is high and decrease it when demand is low, not taking into account the baseline sales that would have occurred organically without increased marketing efforts. Thus, the underlying demand affects your ultimate expenditure. Notice that we cannot see this demand. It is an unobserved co-founder. Now, what does this lead to? Well, you might deduce that paid search is very effective since you notice that an increase in budget on paid search seems to have a great impact on sales. But you should ask yourself, is this really due to the increase in budget? It could be the case that these conversions would have happened organically anyway. Thus, the expenditure was just a waste. But due to the unobserved co-founder demand, it seems like the paid search expenditure was beneficial. Furthermore, due to the ecosystem in which certain campaigns operate, such as the Google campaigns targeting search queries, customers are essentially self-selecting themselves into the treatment, or in other words, our ads/expenditure. We refer to this as selection bias. Now, this means that certain ads will solely target customers who have shown an interest in our products. If we then try to compare such ads with ads that are targeting customers who have not shown an interest in our products, we run into issues. We might see a strong correlation between the search ads and sales, but do they actually incrementally lift sales? I want to highlight that we opted not to include data-driven multi-touch attribution in both the report and the webinars. Firstly, there is no inherent magic in data-driven MTA. It merely reflects correlations and is susceptible to the same selection bias issues we just discussed. Moreover, it encounters challenges in describing time-varying dynamics, lacks consideration for impressions, and faces the likelihood of diminishing utility over time due to increasing tracking regulations and the decline of cookies. In order to answer causal queries, it is essential to comprehend the factors that truly influence our results and the mechanisms through which they operate. So, how should we understand these issues better given our context? Causal graphs seems to be the go-to method. By depicting the cause and effect relationships in our environment, we can understand how different marketing entities impact different outcomes, such as web traffic or sales. It also helps us to understand which issues we will encounter when we try to determine the effectiveness of different marketing entities. In a causal graph, we depict the variables by nodes, and edges denote the causation of a variable on another. We can then use a set of rules from the theory of causality made by Judea Pearl and his colleagues to understand which impact we can infer and what we need to do to infer them. Typical criteria include the backdoor and front door criterion. Now, stating their definition is out of the scope of this session, but if you're interested in the definition of these concepts, you should review the report. However, we can give an intuition of how this works. It might be easier to comprehend these issues in a context that does not encompass marketing but daily life. Therefore, consider the causal graph depicting how wage is affected by a set of variables. Let us assume that we want to estimate the impact of education on wages. Furthermore, we assume that we only have data on education and wages. Thus, assume that we do not have data on family income, SAT scores, and intelligence. We can then notice that we have an edge entering wage from family income and an edge entering education from family income. This is what we refer to as a co-founder, and since it is unobserved in this case, we refer to it as an unobserved co-founder. We can also refer to this as an open backdoor. Now, notice that we also have an open backdoor via intelligence. This is what we can infer with the help of the backdoor criteria. Essentially, we try to find a path that has an edge entering our outcome variable as well as our variable of interest, and we do not have any data that can block this path. Now, what does this lead to? In this case, if we were to set up an equation where we try to infer the impact of education on wages by solely using data on education and wages, the inferred result would be highly biased. This is why we need causal graphs and the theory that comes with it, to be able to identify which effects we can measure without biases and what we need to do to mitigate these biases. Now, we will take a look at how we can model our environment with causal graphs. First of all, this is a vast simplification of the environment we're trying to model. A broad array of other variables can be considered, and the interactions between the grandparents of demand can be highly complex. Furthermore, some of the effects on sales may not be significant when controlling for the mediating variables. However, This causal graph illustrates some essential properties. First, we assume that the underlying demand or baseline sales is driven by seasonal, cyclical effects and trends that we cannot observe. We can try to estimate them based on the factors that drive these effects, such as the day of the week and pay dates. Secondly, it is essential to note that we assume that our marketing on upper funnel activities, such as Facebook traffic expenditure and Google display expenditure, has a lagging effect on sales. We assume that the spending on upper funnel activities has a more significant lag since they intend to work on awareness and consideration, not direct sales. Therefore, we assume a lagging effect due to the time it takes for the customer to go from being aware of the products to considering a purchase. While we can definitely argue that the spending on lower funnel activities also may have a lagging effect on our outcome variables, especially when considering offline sales as part of the outcome variable. But I chose to not include this for simplicity. Lastly, the most important thing to note is that this underlying demand affects our spending on lower funnel activities, as well as our outcome variables, search queries, web traffic, and sales. This will lead to endogeneity issues and subsequently identifiability issues, or in other words, biases when we try to estimate the effect of our spending on sales. This open backdoor is notoriously hard to close, since it is hard to find measures for demand that are trustworthy and applicable to a single client setting. So how can we solve this? By experimentation. By intervening on those variables affected by demand, regardless of demand. But then the question arises. These experiments cost money. So we need to balance our experimental efforts with trying to maximize sales. Ultimately, these experiments are only worthwhile if they can help us achieve more sales later on. This is what we will discuss now. What it really comes down to is to devise optimal budget plans. However, as we have discussed, it is not as straightforward as it might seem. Since our models can yield biased estimates, we need some sort of way with dealing with these biases. Thus, we might need to experiment. Furthermore, we might ask ourselves when we should revise our budget plan and deploy a new one. Furthermore, how long is the horizon for our budget plan? Lastly, which entities should we allocate budget between? Should we consider campaigns, channels, or ad sets? And how should we do to strike a balance between experimentation and just maximize sales with the information we have right now? Should we try to intervene as much as possible during this period to get accurate estimates for the next period, or should we just try to maximize sales as much as possible during this period, not considering the identifiability issues? Furthermore, how can we use the insights from our models in this process? Assuming that we get estimates that depict uncertainty, how should we let this uncertainty guide us in our optimization scheme? Should we be optimistic, or should we try to optimize for the best outcome given that the worst scenario occurs? These are all critical questions to ask yourself when devising budget plans. So, how do advertisers in general go on about this, and what kind of issues do we encounter in the conventional approach of budget allocation? This is what we will discuss now. The conventional approach of doing this is the following. First of all, in general, the actual media mix modeling is either distributed to external companies specializing in data analytics or distributed internally to divisions not actively participating in decision making. The budget plans are then made by managers who are solely involved in the decision making and not the modeling process. Budget plans usually cover longer periods, often structured on a quarterly basis. During each quarter, a fixed amount X might be assigned to platforms like Facebook, while another fixed amount Y may be dedicated to platforms like Google. These budget plans are then reviewed and adjusted at the end of each quarter. However, there are a lot of issues with this approach. First off, in general, companies do not consider the exploration versus exploitation trade-off when doing this. In general, they deploy an exploitative approach. In other words, they assume that their model is perfect and optimize the budget assuming that the external company's estimates are accurate. They do not aim to explore the environment to encounter a better model. In other words, improve on parameter estimates, which can be very beneficial in the long run. Furthermore, When advertisers/managers do decide to experiment, the experiments range over short periods. Furthermore, due to the lack of insights into the modeling aspect, they tend to create experiments with strongly collinear expenditures. Moreover, the budget plans are generally implemented on a channel-based segmentation, whereas SEM specialists decide on budgeting between campaigns and ad sets. Typically, the SEM specialist's work is assessed based on the conversions in Google Analytics that got attributed to the campaigns they manage. There are several issues with this. First of all, running a single experiment over a short period and then thinking that this experiment will tell us the effects of marketing during another period is highly problematic in our scenario, since we're working in a non-stationary environment, whereas the effectiveness of marketing and the underlying demand changes over time and in response to events. In other words, running an experiment in, for example, March may tell us very little about the dynamics in August. Furthermore, decoupling the modeling process from the decision-making process can pose all sorts of issues, since the people making the decisions may not fully comprehend the issues that the modelers face. Moreover, evaluating different stakeholders in this process based on their individual impact without reviewing it from a higher level is highly problematic. This will probably lead to SEM specialists aiming to get as many conversions as possible in the short term for their specific campaigns, not taking into account the upper funnel marketing effects or the sales that would have occurred organically. We need to assess different budget strategies on a high level, reviewing total sales and not just sales attributed to specific campaigns in Google Analytics, since that would be very biased towards lower funnel marketing. Moreover, by constructing a budget plan over a long horizon, such as a week, a month, or even a quarter, that maintains a consistent spending level across all time steps within that span, advertisers will miss out on the demand spikes that may occur due to the day of the week, the day of the month, etc. Also, by revising their budget plans solely every quarter, they will not learn as quickly as an advertiser that is revising it every day, which will be able to pick up on the latest info and construct budget plans accordingly. Before discussing how our approach can alleviate some of these issues, let's first take a closer look at the exploration versus exploitation trade-off. I mentioned the exploration versus exploitation trade-off briefly in the last slide. I thought I should go a bit deeper into this since it is essential. Now, imagine the following scenario. A new restaurant has opened in your neighborhood and you need to decide if you should go to this restaurant or the one you're already familiar with. You're then facing the exploration versus exploitation dilemma. Now, let's say that you know the food is good in the restaurant you're already familiar with. Should you risk visiting the other restaurant, which may have better food, or should you stick with what you already know and go to the restaurant you're already familiar with? This is what the exploration versus exploitation dilemma is all about. In our context, should we devise a budget plan to learn the most about the effectiveness of our marketing entities, or should we just try to maximize sales without explicitly trying to learn about the effectiveness? Now, what would it mean if we chose the budget plan yielding the most information about effectiveness? We would probably get fewer sales, but in return, we would probably be able to discern the impact of our marketing investments more effectively. Now, when we revise our budget plan, we will have a better understanding of the impact of our marketing investments, since we have experimented instead of just trying to maximize sales. Thus, during the following period, we may choose to act exploitative. And now, since we have better information, we get higher total sales due to our exploration in the previous period. Exploration may also be beneficial in our context to address some of the challenges of modeling marketing response that we have discussed, such as multicollinearity, low variance in expenditure, and endogeneity. When we have historical data with some multicollinearity or low variance in expenditure, it can be hard to accurately attribute the effects the marketing campaigns had on sales. Furthermore, to address the endogeneity issues we discussed in the previous sections on causal graphs, where demand affects both our outcome and our expenditure, we might need to intervene on our expenditure variables irrespective of demand, to be able to discern the effect of that variable on sales. But since exploration costs money, how should we balance this with exploitation? This question has been a central one to the sequential decision optimization communities. Sequential decision optimization involves a repetitive cycle of decision making and response retrieval. As depicted in the graph, we have an agent. You can think of it as an automated program that makes decisions. These decisions, such as what should I spend today on different marketing entities, gets deployed to the environment, in our case, the digital platforms. Then a response, such as sales, is retrieved and the process repeats. Extensive literature exists on this subject, and individuals with a technical background may recognize communities like reinforcement learning and bandits. These techniques, integral to our daily lives, are employed in applications such as ChatGPT, which refines responses using reinforcement learning. A crucial element in these communities revolves around the balance between exploration and exploitation. This aspect appears overlooked in conventional budget allocation, where the emphasis is primarily on exploitation. And as we established in the previous slide, exploration may be beneficial, and we need to balance our explorational efforts with our main objective of maximizing sales. In our automated machine, our algorithms predominantly stem from techniques developed in these communities. For someone with a technical background like myself, it's disconcerting to still witness companies relying on human-made decisions based on intuition and feelings, instead of basing them on data and employing techniques that has been studied for decades that can effectively balance exploration and exploitation. I am certain that in our context and this day and age, we have readily available control/machine learning techniques that can make decisions far more effectively than the typical advertiser. For those interested in delving deeper into these techniques, please refer to the report, as it is beyond the scope of this session to explore these respective communities extensively. Let's now delve into our strategy and explore how our approach can mitigate the issues inherent in the conventional approach of budget allocation. In our approach, optimization is conducted with a horizon set until the end of the current month. For instance, if the current day is the 2nd of January, our budget plan extends until the end of January, resulting in a horizon of 29 days. Furthermore, we consider daily allocations. This means that we consider the attribute of each day over the horizon, such as the day of the week and day of the month, if it is a holiday or if some special event occurs. As we have discussed, these factors impact demand, and demand impacts our outcome as well as the effectiveness of our marketing. This lets us capitalize on the demand spikes typically seen in our environment, where, for example, the days after the 25th here in Sweden could be more effective for advertising than the days just before the pay dates. We also consider a campaign-based segmentation. There are a lot of reasons for this. First of all, if we would have considered a channel-based segmentation and one of our clients decided to remove or add a campaign, the underlying data generation process would change. And in some sense, the historical data that we have would have been obsolete. This would pose all sorts of problems, and we would need to find an algorithm that is highly adaptive. Furthermore, by considering a campaign-based segmentation, we can handpick campaigns that we know have expenditure that has been strongly impacted by demand for experiments to identify the true impact of these marketing entities on sales. Moreover, we revise the budget plan daily. This allows us to learn faster, since we can quickly pick up on environmental changes and adjust our budget plan accordingly. So to summarize, by revising our budget plan daily and choosing a campaign-based segmentation where we optimize over a horizon set until the end of the month, we can capitalize on demand and effectiveness spikes occurring on a particular day of the week or specific day of the month. We're also able to handpick problematic, in the causal sense, campaigns to experiment with. And we're also learning about the environment faster. Furthermore, we use techniques from the aforementioned sequential decision optimization communities to balance exploration and exploitation. Now, the amount of exploration needed can vary a lot depending on the customer. For certain clients that have historical spending that does not exhibit a lot of multilinearity, have conducted a lot of experiments with great variance in expenditure not affected by demand, the amount of exploration required will not be as much as for a client that have not experimented at all previously. This means that for certain clients, the impact might come later on than for others. This is due to the fact that we might need to explore unexplored regions of expenditure to find accurate models. When we have found accurate models, we can then generate more sales than what would have occurred if we had not experimented. since we can more accurately depict the effectiveness of different marketing entities after the experimentational efforts. On a high level, we can envision our approach as follows. First of all, we identify the properties of the client. This includes, for example, which sector the client operates in, which country they are targeting with their campaigns, and the constraints the customer has set with regards to the total budgets, minimum spending requirements on any of the platforms or campaigns, etc. Then, we retrieve data from the sector and the targeting country not belonging to the customer. Since we are a vendor of these services, we have access to vast amounts of data from different sectors and countries, which makes it possible for us to come up with conclusions about, for example, the reach in a particular sector or the time-varying attributes in a specific country without factoring in the historical data of the client. Then we of course also retrieve the historical data of the client. We then proceed to find the most accurate model given our information about the sector, the targeting country, and the historical data the client possesses. I want to point out that we may also decide on budget plans that explicitly aims to find a more accurate model instead of just assessing models based on historical data, which analysts typically tend to do. We then estimate this model, retrieving uncertainty estimates and different statistics about the impacts of spending on different marketing campaigns. We then decide on experimentation or exploitation. In reality, this step ties in with the next step, which is to optimize over the horizon, but for clarity, I chose to set them up as different bullet points. This decision is made based on historical data and its properties. We then optimize over the horizon, the whole horizon now. This is important to be able to capitalize on, for example, demand spikes during certain days of the week or days of the month, or special events, etc. We need to take into account what happens in the future to effectively, for example, save on money today to spend it later if the effect is deemed greater later on during the current month. It also helps us adhere to the budget constraints the customer imposes. We then deploy the budget for the current time step and solely for the current time step. Notice that in the previous bullet point, we optimized over the whole horizon, and in this time step, in this bullet point, we solely deploy the budget plan for the current time step. This is where an automated system really shines in comparison to a manual setup. To do this manually every day would require a vast amount of effort and time, but by having this automated, we can just let the system do everything for us. The reason for just deploying the budget for the current time step is that our beliefs about which model is the best, what its parameters should be, etc., can change from one time step to another. This is why we even explore in the first place, to find a better, more accurate model. Then, at midnight, we retrieve our response, thus sales or conversions for the previous day. Then, we repeat the process from step 1. For the audience that wants to dive into the details of our algorithms, I recommend studying the report. So to summarize these 2 first sessions of this series on sequential decision optimization with media mix models, we have discussed models that we use to describe the dynamics within the environment, such as saturation, ad stock synergies, and time-varying factors. We also reviewed an actual real-world model. We have also discussed the environment in which we operate, and the challenges we might encounter when trying to model the impact of marketing efforts on sales. We have discussed multilinearity, low variance in expenditure, endogeneity issues, etc. Today, we discussed causation and correlation, factors that have a vast impact on our ability to accurately attribute, for example, conversions to campaigns or determining which was the best ad. We also touched on sequential decision optimization, explaining concepts such as exploration versus exploitation, and finally, we demonstrated our approach to this problem. These 2 initial sessions were designed for marketing professionals without a technical background. Consequently, technical details and in-depth reuse of these concepts were intentionally excluded from the scope. The upcoming session will review and discuss the report we have published detailing our approach to optimizing marketing expenditure. It will cover each section of the report, emphasizing the key factors within each section. This session is notably more mathematical and is primarily tailored for professionals with a technical expertise and fellow researchers. While the intended audience of the previous sessions included marketing professionals without technical backgrounds, it is assumed that individuals that will view the last session and the report are acquainted with expertise in machine learning and control. However, even for those lacking this expertise, there is valuable information to gain. Therefore, I highly recommend reviewing both the report and the upcoming session for a comprehensive understanding of our approach. Thank you.